Hey folks, welcome back. In this video, we will be talking about Python math module. So math module provides mathematical calculations or computational functions. So it includes mathematical functions, trigonometric functions, and statistical functions, logarithmics, and etc. So it also provides the constants. So let's get started with it. So here we can see that it provides pi value, math.pi, and exponential value, that is Euler's number e. So that is math.e, and we have tau value for a circle constant, math.tau, and we have inf, that is infinity, positive infinity, to represent the infinity, and we have nan, so that's not a number. So when we want to represent not a number, so we can just use math.nn. So these are the constants. So let's go to playground and let's execute the code and see how we can use the math module. So first we need to import the math module by using import statement, import math, math. So once we do that, so we can use the math module to print math.py to get the pi value, cd space math module, and then clear out python playground.py. So if we run it, so we get the pi value, so that is math.py, and the next we have math.e. So let's clear this out and run. So now we got math.e value, and what next we have tau, math.tau. So here we can see that tau value as well, and math.inf to represent the infinity, positive infinity, and so let's say if you want to get negative infinity, we can do something like that. We just need to add this symbol before, and we have nan, is nan, not a number, so we just need to do this. So this is how we just use the constants of a math module. So let's look at the trigonometric functions. So here we have math.sine that represents sine value of x radians, and math.cos, that is cosine, returns the cosine of x in radians, and math.tangent, that is math.tan of x, that returns the tangent of x radians. And so let's look at first these three functions, and let's look at the other inverse of the sine, cosine, and tangent functions later. So let me copy this and go to playground. Just remove this print statement, add it. We just need to use print statement here. So yeah, that's it. Let's run it. Python playground.py. So we got one. So similarly, we can use cosine, and let's paste it here. Looks like we didn't copy it properly. So let's paste it. Yeah, I got it. Print math.cos. So now we got the cos value for that, and we have tangent function as well. So let's copy that and paste it here. It's like accessing the attributes of math module, just like all other modules. So we can see the value, and similarly, if we look at arc sine, so it is also same, just like cosine and sine. So it's just an inverse of sine. So we got the value there. and we also have our cosine, that is a cos. So we got the value as well. Let me clear this out. So similarly, we can look at other functions as well. That is arctan, that returns the arctangent of x in radians. So let me copy that and paste it here. So let's run it. So now here we can see the value. Similarly, we can check the a tan 2 function. So that returns the arctangent of um, y or x in radians, y with respect to x. So let's copy this and try it out. So it returns the value, and we have two functions, that is angular functions. Math dot degrees, that converts an angle x from radians to degrees, and math dot radians, so it converts the angle x from degrees to radians. So it just converts the degrees to radians and radians to degrees. So let's copy that. Okay, let's paste it and remove this backward. Clear this out and run it. So now we got 180, and let's copy, I mean, let's convert that to radians. Pulse print. Let's remove this as well. Clear this out and run it. So now we here we can see that we got 3.14, and here we have 180 degrees. So let's clear this out, and yeah, that's all for the um, trigonometric functions. And let's look into general mathematical functions, like finding out the GCD, LCM, square root is finite, and all other things. So let's look at the theoretic functions. So let's say we have two numbers and we want to find GCD of it, that is greatest common divisor of integers a comma b. So let's try that out. So for that we just need to use math.gcd. So this function, so it takes the two numbers and returns the greatest common divisor. So let's try this out in playground. Go to playground and remove this this stuff and paste it. So here we can provide any two numbers. I just take 12 comma 15. Okay, let's run it. Python playground.py. So we got 3. So 2 is 12 is divisible by 3, and 15 also divisible by 3. So that is the greatest common divisor for this these numbers like 12 and 15. Let's go back, and let's find out the LCM for the same. So that is least common multiple of integers a comma b. So let's try that out. Okay, let's go to playground, and instead of GCD we just need to use LCM, least common multiplier. So let's clear this out and run it. So we got 60. And we have one more function, that is integer square root of two numbers. So we just need to give an integer, and then it just gives the square root for that. So let's try that out. So here we just need to give the number inside square root. Is I square root is nothing but integer square root. So let's save it and clear this out and run the code again. So we got 4. Let me give 100 here. So we should get 10. So it works just fine. Similarly, we have is finite. So that checks whether the given number is a finite number or not. So let's try that out in playground. So is finite Python playground.py. So it returned the boolean value, that is true or false. So let me give math.nan. So it returned false because that's not a valid finite number. So let me give infinity math.inf and try that out. Still we got false value. So let's try with the floating point number, that is 1.23. So we got true. That's because it's a finite number. So that's how we use is finite to check whether the given number is finite number or not. So let's go back here again and let's look at the other function, that is math.isNan. Check whether the given number is not a number. So let's go back to playground and use isNan and try this out. So we got false. That's because it's not a nan. Let's use math.nan and check this out. So now we got true value. That's because it's not a number. That is math.nan. So we use this isNan function to find out whether the given number is nan or not. And we have factorial. So it just takes the number and it gives the factorial of that number. So previously we have written a program for that, but we have a built-in function for that in math module. So let's try that out. Math dot factorial of 5, that is all the numbers 1 to 5. So when we multiply that, we get the value. So let's run python playground.py. So we got 120. So when we give 6, then we should get 720 for this value. So yeah, so that's how it works. And we have permutations and combinations, that is math.perm for permutations of n items, k taken at a time, and for the combinations of n items, k taken at a time. So let's try that out. We should get the proper number for that. So let's try that out and see. Let's run it. So we got 20. So here we have 5 items, and if we take 2 at a time, so we get permutations of um, all possible permutations for the 5 items with 2 taken at a time. So we get 20. And let's try for combinations of it. So if we try, we got 10. So these are the unique combinations that we can create with the 5 items, 2 taken at a time. So yeah, so we have functions for that as well. So math.prod, so it takes the iterable elements like list, tuple, or set, or any other iterables, and it just multiplies the values and returns it. So let's try this out. Let me copy math.prod and just replace this method with prod, and we just need to provide iterable here. So I'm just using list for this, comma 2, comma 3, comma 4, comma 5. So yeah, we got 120. So that's how it works. So let me convert this to a set, and then also it works fine. Let's try this out. So still it works. So if I use tuple instead of set or list, then also it should work. So it's working fine for all iterables. Yeah, so that's all for the theoretic functions in Python, mathematical theoretic number functions. So let's look at power and algorithmic functions. So we have math.pow to raise the power for x, a power of y. Let's look at that. math dot power. So we want to do 2 power 3, 2 raises power to 3, then that should return value 8 for us. So let's try that out. Python playground.py. So we got 8. Let's say here we have 10, we should get 1000 for this. So yeah, it works great. And we have a square root, it returns a square root of a x. So let's say q or t, and I just want to find out square root for 3.9. Python playground.py. So it is 1.97. So if we try to use I square root here, so let's see what happens. It did throw error. That's because float number cannot be interpreted as an integer. So that's why here we should use square root for floating point numbers, and we should use I square root for integer values. Yeah, that's how square root works. And we have math.exp, that is exponential value or Euler's value. So if we give the x, that is, let's say if we give x value as 2, that is e power 2. And if we give x value as 3, then it's e cube, that is e power 3. So it just works like that. Let's use it. Math.exp of power 1. So that should be equals to math.e. So previously we discussed Euler's constant, that is math.e. So let's try that out. So we got the same values for both, so it just works. Let's use e power 2, then we should get the power of this number, that is 7.389. So that's how we use math.exp to get the power of e square, e cube, e power 4, e power 5, something like that. So let's go to the next function, that is log. Log x, that just returns the natural algorithmic value for x. So math.log10 just returns 2.30. So let's try that out. And we can also use base in other functions. So math.log10, let's run it. So we got 2.30. So in anywhere, if we want to use logarithmic values in calculations, so we can just use math.log to find out the logarithmic value for natural logarithm. So let's look at the other function, that is math.logx base 10, or we can give any base. It's not just like giving base 10. But for easier calculations, I'm just using this example, that is math.log 100 to base 10. Okay, let's try this out. So we got 2.0, and we should also use, we can also use any value here, like base 2, base 3, base 4, anything, whatever the value that we want. So I'm just passing the base 2. So we got 6.64 for the base 2 value. So if we give base 10, the value changes. And if we give base 8, and also the value changes. So that's how we can use a math.log. So this is the value and this is the base. So it just needs 2 parameters for that. And we have math.log2. Log2 and log10 are most used algorithmic values. So just it returns the base 2 logarithm of x, and log10, it returns the base 10 logarithm of x. So let's try that out. Math log 2 math. Okay, I should use print statement. Print math.log 8 base 2. So try that out, and we got 3 value, that's the correct value. And let's use 10 and use 100 here. So we got 2, that is the expected value for math.log 10, sorry, math.log 100 and base 10. Yeah, so that's all for the logarithmic and power functions. So for other calculations, we have external Python packages, that is pip packages. So if we want to do more calculations based on the requirement, then we can choose one of these existing packages for that. So that is NumPy, SciPy, Pandas, Scikit-learn, Keras, PyTorch, and TensorFlow. And we also have other packages, but these are the most used Python packages for data analysis and calculation, mathematical computations. So that's all about the Python math module. So you can go to the Python official documentation to learn about it more. Like there, they have given the full description and how it works and what Python module does. So yeah, I just gave a gist of it. Yeah, that's all for this video. So if you find this video is useful to you, and then like the video, share it with your friends, and don't forget to subscribe to my channel. Thank you.